We have another half-hour talk. I think we have three half-hour talks before lunch. And we're going to start with Nelly, who's going to talk about SignalR, which I think is very cool, in a serverless sort of context. So please welcome Nelly to the stage.
Hello, everyone. Can you hear me? Okay. Hello, and welcome to this session, and thanks for joining me. My name is Nelly Sattari. I'm a lead developer from Challenger. I'm going to talk about serverless real-time applications, but before that, I would like to make sure that we are all on the same page in regards to real-time functionality. So let me share one of my experiences with you. I work in Sydney CBD. I came from Sydney. I work at number 5 Martin Place, and we have a very luxury reception. So every week, we actually order a beautiful, expensive, big flower bouquet, and then at the end of the week, since we are a financial company, we are not going to throw it out. It's still fresh and gorgeous. So we put in a bid for the flower, and everyone across the company can join to the website and place their bid. The problem is whenever I participate, I actually win the competition. People think I'm either so lucky, which I don't deny it, or I place a much higher bid than other people, which is not true, because I normally win with a couple of, like few cents differences. The reason is when I opened the website, I realized that there is no real-time functionality in our website. So maybe 2 minutes or 5 minutes to the closing time, I pop into the website and take a very high technical solution, which is this one. So I keep pressing F5, and I can see all the latest contents in the website, and I can see who placed how much, and then I just add a few cents, and I submit my request. Obviously, I'm a developer. I said I submit my pull request. And I submit my request. So I acknowledge that this is not really a fair solution because we don't have enough transparency, and someone like me with a little bit more knowledge can win the competition. So I came up with a proof of concept for my company to show them how easily we can move to real-time applications and get these features on the website. So now I built this application, deployed it to the Azure, and you can see I opened 2 browsers. Whoever pop into the website, you can see that other people can be informed. Nelly is joined, and whatever you place as a bid, immediately, without any delay, the other people can see. So you don't need to press F5 or taking some workaround. And it's probably one of the best solutions because you have enough fairness, you have enough transparency, and people get the equal knowledge, and you include basically everyone. So the real-time applications are not the one that clients pull the data periodically. It's the one that server push the data once it's available. And the website with high-frequency updates probably are the most suitable candidates. And the examples are like any social applications where you know how pleasant it is to get the notifications in real time. Any online dating applications. Nobody will date with someone who is not responsive, so you need to get the data and messages quickly to be able to respond. Tracking applications like tracking your Uber ride, your shipping package, or maybe sometimes your your kid in the school car. Different variety of online gamings where you will lose the game if you have even 1 second delay. Any kind of dashboard applications, including incident, security, or flight dashboards, where due to any event, you need to get informed that something has happened. So you might ask this question that how I can add this functionality, real-time functionality, into my application. So Azure SignalR Service is one of the services that you might need to look. Basically, we need to use SignalR, which is an open source library, in order to add the real-time functionality to the website. So SignalR is an open source library which was shipped with ASP.NET and later on with ASP.NET Core. It means that we are kind of dependent on the ASP.NET platform. So two main features are required where you want to say that my application is real-time. One is basically you need the persistent connections between client and server. And the persistent connections can be established through different methods. One of the most famous one is the WebSocket. That SignalR under the hood will manage it. The other one is bidirectional communication, where client can make a call to the server, and server can also make a call to the client, and they can send data to each other. Can I open a parenthesis here? So I want you to think in the background of your mind that while we have these persistent connections between client and server, how it would be possible to use serverless while we don't have any server, basically, like don't get me wrong, not that we don't have any server, we don't have any like dedicated virtual machine which is running all the time. Just keep it in your mind that how we want to get to this solution, but I'll explain later. So with this traditional SignalR real-time applications, we have lots of challenges. The challenges, the most important one is when your website is hammered by countless number of users and it's just under the high load and high traffic. It's not easy to manage. I'll show you one aspect of this problem, and there are more, but this is the most important one. So although the persistent connections is the required feature for having the real-time applications, it's actually problematic as well. The reason is persistent connections consume lots of resources from the server. The thing is, persistent connections are not like HTTP request and response, where clients send the request, get back the response, and go away. It's not like that. Persistent connections stick to the server and stay connected forever, maybe, till you actually close the browser. So it makes the server to be overloaded and reach the capacity, the maximum capacity of the resources so quickly, much quicker than normal applications. And it makes your server fall over and overloaded. As a rule of thumb, what we do is scaling our servers, which is fine. But the problem is in the real-time applications where you need your clients to be collaborative and they want to send messages to the other clients, talk to the other clients, and broadcast messages, it's not that easy. It's a different story. So let's say the client send a message to the server, and then server knows who are connected, where broadcast the messages. So far, so good. But how about the other server and other clients? They have no idea about each other, right? The server doesn't know what other servers are spinned up already. Here is the actual problem. So the traditional approach is implementing your own scaling solution, getting your load balancer, using Redis cache and SQL database to have a kind of backplane solution and propagate the connection information between all the servers, which is not really easy. It's complex. It's overhead for developers. And you need to make sure that you actually manage the monitoring and load balancing and all the required services, which is not the best solution, obviously. So Azure SignalR Service adds this simplicity to your large-scale applications where there are lots of users concurrently connect to your website. Azure SignalR Service works as a proxy, which means all the persistent connections are delegated to Azure SignalR. It means that your app server is no longer accepting any connections. And the question I ask you to have in the back of your mind that how we can make sure that with serverless we can get the real-time functionality probably can be fixed by this solution, because app server is no longer accepting the connections, which is fine. I'll walk you through more. So speaking of this proxy, client make a call to the function, and instead of staying connected, it actually just get back the URL of Azure SignalR and then stay connected to the Azure SignalR instead. App server will do the same thing. So they both connect to the service. Since the service sits between client and server, The data channel is established between the client and server through SignalR Service. So if we want to send a message, it's easier. We actually send it to the SignalR Service, and then SignalR Service knows about all the servers, and obviously servers knows about the clients. So they will broadcast messages to everyone. Look like our problem is kind of solved, and the Azure SignalR Service is fully managed service, which means you don't need to be worried about monitoring or logging the information or anything else. Basically, it's just a fully managed service. So it's really easy to set it up. It's just one single line to create and deploy your Azure SignalR Service, which is this line. This is a command, Azure CLI command, but you can use ARM template if you want. You just run this command, and then to confirm your service is created, pop into the Azure portal. This is Azure portal, in case you haven't seen. Find your recently created service, and then you can see, like all the information about service, including your connection string. So through this connection string, you can connect to the service. Having a flashback to my bidding application, I used Azure SignalR Service, I used the ASP.NET Core and Vue.js as a client application. So I'll show you the code. It's simple. We just make sure that we inject SignalR to our application, and we make sure that we actually use Azure SignalR by passing the connection string. Then you create your route, so clients can hit this route, and then they will fall into hub class. Through the hub class, they actually have access to all these methods in the hub class, so they can basically make a call to the server's events. And then server also, through the SignalR, has access to all the events in the client side. So basically, it can make a call to all clients, a group of clients, or maybe one client, and then pass the message to the clients. So sounds good. All critical issues are solved, which is good, but we still have a problem. The problem is, although SignalR is a great library, we are badly coupled into ASP.NET. So if you are not in the .NET stack, or if you're not even a .NET developer, it means that you cannot really use SignalR, which is not good. On the other hand, if you look at my code, you can see it's quite on the monolithic design, which means everything from accepting the connections, managing connections, broadcasting messages to the clients, or in the real life, probably you will have some database operations as well that you want to manage in your code. So everything is in one big chunk of code, which is the ASP.NET code, and you somehow want to get rid of that. Going serverless will give us this opportunity to actually break down our big chunk of code, our monolithic code, into a couple of event-driven APIs, which is really good. And it actually move us basically through using the microservices instead of monolithic applications. On the other hand, what if I'm not a .NET developer? Should I be excluded? No, you don't need to. You can basically use Azure Functions using your language of choice, JavaScript, Java, Python, or whatever, and then get the real-time functionality out of this. In order to switch to serverless, it's really simple. You just open your portal again, find the SignalR service that we just created, and on the setting, you basically switch the mode between classic and serverless. That's it. You don't need to do anything else. Then you need to replace your ASP.NET application with a couple of Azure functions. One of the required one is the negotiate function, where your client make a call to the negotiate function and will get back the URL of the service, SignalR service, and then easily connect to the SignalR service, which is good. Probably you need to have another function as well in order to broadcast any message in your system. So let's say you have a message and you want to broadcast it. Same scenario, you just have another function, broadcast, and then pass the message to all clients. Going back to my point that we don't have dedicated virtual machine. So in serverless mode, when you like make a call to the function, the server will spin up and then will execute the function, and then everything is done. The function will going down, and then you don't have any other functions, servers running. So it means that the server is not connected to the Azure SignalR, unlike the ASP.NET application. This makes me think of clients as a listen-only mode, which is fair enough, because there is no server that clients want to pass the message to them. And obviously, you have lots of benefits by moving to serverless. You are not paying for a dedicated app server. You are just using all the API and microservices. This is the restriction we have. So my point is just choose it carefully and make sure that the scenario that you want to move to serverless is just reasonable and it suits your, serverless suits your scenario. The scenario that I was thinking and I built a demo for you is this flight center application. So all over the world, whenever a flight is landed, in this website, whoever is connected to this website, they can see the flights. So the flights will be broadcasted to all the clients. These kind of scenarios, make sense to have the serverless because clients are not collaborative, they're not really active that much, so they just get broadcasted, which probably is the best scenario. So how we combine this Azure SignalR, Azure Functions all together? Azure Functions basically offered a very productive programming model, which as a developer, I really like it. So it's triggers and bindings. Triggers are the one which makes your function to be invoked. They actually cause your function to run. And bindings is the way that your function talks to the other functions in order to pass any data to them or getting any data from them. So Azure Functions can leverage one of the bindings, which is Azure SignalR binding. We have lots of bindings that you can use, and this is one of them to add the real-time functionality. Going back to my flight center application, let's say we have a third-party API which kind of implements the flight into my queue whenever any flight is happening. And then the queue basically can be a trigger, right? So the queue triggers the broadcast function and pass the flight message to the function. The function uses the output binding, SignalR output binding, and pass the same message to the binding. And the SignalR binding out of the box knows how to broadcast messages to all the clients. The amazing point is you don't need to write any piece of code. Everything is just through the configuration. So you just, looking at this portal, you define your function, broadcast function. You will say, my trigger is the queue and my output binding is the SignalR. That's it. So out of the box, it knows how, so you don't need to open the SDK, writing lots of hard code and getting these services connected to each other. The only code I wrote is this broadcast function, which I use JavaScript to show you it's OK to use. So basically, this is the parameter which came from queue. So the queue triggered this method and then passed the flight. So you need to create a new object to suit SignalR requirements. SignalR needs the actual message and the client-side event who is listening to the server. So you pass these two, and then you assign your object to the SignalR output binding. And it's done. I didn't hide anything from you. It's what I did, basically, and it works. So I provided some blogs in my, some posts in my blogs and explained everything in detail. So you can see everything about Azure SignalR Service and another post about serverless. So it has all the details, how you can get the serverless, how you can test it locally and publish it to the Azure and everything else. So if you have any question, I'm happy to take. And if you have any further discussion, I'm around all the day here. Thank you so much.